Ladies and gentlemen, welcome to the next session of our tech session. For Q&A, kindly key in your questions at the Q&A chat box. Do visit our virtual exhibition and discover the latest water innovations and technologies. The exhibition will be live for 24 hours during this whole week. Do enjoy the next presentation.
Good afternoon, everyone. Welcome back to our Hall 3, Track 4. My name is Mohammed Sifon from Chemscience Consultants, Sdn Bhd. On behalf of Malaysia Water Association, welcome you to the next presentation. The next presentation will be on the topic of water quality of an integrated rainwater harvesting system for portable use. It will be presented by Dr. Lavanya Balu, University Technology Petronas, Malaysia. Let me introduce Dr. Lavanya for her presentation today. She's a senior lecturer at University Technology Petronas, or UTP. She obtained her Bachelor of Science in Industrial Biology and Master of Engineering in Environmental Management from University Technology Malaysia. And she obtained her PhD in Civil Engineering specialization in Environmental Engineering. Dr. Lavanya's research has primarily focused on water, wastewater, and sludge waste management and treatment. She has published several scientific papers in international journals, has indexed 10, and to date, the total citation is 378. She is also a registered professional technologist. Besides teaching, she has conducted several open short courses with industries, consultancy projects, and have successfully secured several research grants. Dr. Lavanya, the floor is yours.
A very good day to everyone. Welcome to Malaysia International Water Convention 2021. I am Lavanya Balu from Civil and Environmental Engineering Department of University Technology Petronas. Today, I would like to share one of my research topic that is on water quality of an integrated rainwater harvesting system for portable use. Let me start with some background introduction. That is, in this era, the water supply delivery system in Malaysia is indeed efficient and widespread nationally. Yet, the country is still facing sudden water disruption from time to time and surface water level depletion crisis, especially once the water pollution crisis or incident happen, the surface water also will be polluted and it will interrupt in the supply of clean water. And at the same time, the recorded population growth of Malaysians is also resulting to increasing clean water demand in addition to Malaysians' high consumption of water. It is recorded that our water consumption is higher than the level that is allowed by WHO or recommended by WHO, which is 165 litre per day. So our consumption is already almost 210 litre per day. And these incidences are urging the country to seek the alternative clean water supply as soon as possible. One of the way is to harvest, treat, and reuse rainwater through rainwater harvesting system. Malaysia receives abundance of rainfall annually, making the country well fit to practice rainwater harvesting system. However, the implementation of rainwater harvesting system is still underrated, although the practice has been supported and promoted by the government since 1999. The present and future water crises are urging Malaysia to seek clean water alternatives to cater the increasing demand. To date, there is lacking of new study on rainwater harvesting innovation, specifically in terms of hydraulic effect context. There is a possibility for rainwater to carry nutrient pollution, microbial pathogen contamination, heavy metal, and pesticides, leading to the requirement of treatment of rainwater before consumption. Nevertheless, Even with the addition of the first flush diverter in the system, the harvested rainwater is still not eligible for direct consumption and is still contaminated. And let us see what is rainwater harvesting. So it is an art of collecting rainwater, treating and store it in a system for future usage. And we see how it will happen once the rainfall happens. It will hit the catchment area or the roof area, and the water will be running through the roof and will be delivered to the conveyance device, and from the conveyance device it will be later passed through filtration system known as first flush system. In this first flush, the purpose of first flush is to remove the first 30% of the contaminant, because like maybe the roof area is already like contaminated with dust or bird droppings. So once we have this first flush system, it's able to remove the first 30% of the contaminant, and finally it be stored in the storage tank and will be used during emergency situation as an alternative water supply. The novelty of this study is that the innovation to the convention RWH system by integrating the double FF diverters and a custom designed vortex filter and dual part storage tank equipped with a thermostat heater in a subsequent arrangement to improve the harvested rainwater quality that is effortlessly efficient, energy saving, eco-friendly, and with simple installation. Now let's look how the eco-rain works. Once the rainwater passes through the conveyance pipe, it will channel to first flush system. Earliest runoff channeled by the conveyance pipe into FF1, and a ball acts as a seal to trap a volume of contaminated runoff. And the fourth step, the runoff fill up FF1 and spill into FF2, repeated flushing and trapping, and finally the rest of runoff is forced to enter vortex filter. And 6, runoff undergo vortex motion at the funnel with high impact. And 7 steps after the vortex motion, the runoff is filtered for finer particles. At step 8, filter and cleaner runoff is channeled into the storage tank. The filtered runoff is filling up the outer chamber first, that is non-treated part. And the treated part, step number 10, the filtered runoff is next filling the inner chamber volume controlled by ball and seat system, ready for mild heat treatment. Step 11, the rest of the incoming runoff is filling up the storage tank until it reaches the overflow tap and channel out. At step 12, the overflow runoff is released or being kept into extra storage by consumers' decisions. And there is a switch on the thermostat heater. Automatic power cut-off function will be activated once the heater reaches 80 degrees Celsius to set the temperature. And here we can see that the flush out of the runoff trap in FF diverters can be used for gardening or washing car. And the flush out of the unheated filter runoff in the storage tank can use for shower or house cleaning. And the flush out of the heated and filtered runoff can be used for potable activities. So most of the water have been used here efficiently for few of the activities. This research focused on the quality improvement of the rainwater. In the study, several hydraulic event and electrical components were incorporated into conventional rainwater harvesting system installed at a calm environment of a residential area to represent the actual condition. The innovative technology is believed to be a promising solution for enhancement of water security. Let me briefly explain the three major components. Start with double first flush diverters, that is because 2 FF1 and FF2. Two FF diverters tank were arranged in subsequent manner to induce the subsequent flushing and vigorous water drop impact driven by the high velocity of incoming rain runoff from the rooftop and gravity force. And next is the vortex filter. In the custom design vortex filter, the remain of rain runoff that surpass the diversion of FF will undergo the contaminants particle trajectory impact to the versus wall generated by centrifugal force through the swirling motion of the vortex and filtered for final particles by using cellulose 0.5 microfilter mesh. And the dual part storage tank with the thermostat heater is a storage tank is custom designed to consist dual part of chamber, the inner and the outer. A thermostat heater with an automatic cut-off switch is equipped in the inner chamber, set with a certain temperature to conduct mild heat treatment to the 6.75 liter of rainwater that is aimed for portable use. And let's see the sequence of the sample movement. So start with FF1 in this picture. That is the influent rainwater, the first wash off runoff from the rooftop. And it goes to FF2, the second trapping with double flushing impact for later wash off runoff. And it moves to the vortex system where the rainwater runoff that pass through the swirling, impact and fine filtration noted as filtered rainwater at this point, and then next it passed to the for portable use whereby it will undergo mild heat treatment, and this P40 up to P80 indicates the temperature. P is for pasteurization at 40 degrees Celsius, at 50 degrees Celsius and up to 80 degrees Celsius. So the filtered rainwater is heated in a series of mild heating temperature as I mentioned just now, and at this point it is known as treated rainwater that can be used for portable use. And this slide shows the analytical procedure that is according to the APA standard method or ASTM method, whereby physical, chemical, microbiological, and also the heavy metal analysis was conducted on the rainwater sample, the raw and also the treated rainwater sample. And for heavy metal, here we have just analyze the zinc and copper only, because for arsenic, cadmium, lead and ferrum the values drop after the initial batch of samples collected showing their absences. So that's why we neglect all these heavy metals concentration analysis. And all this here it indicates the rainwater quality of the installation site, all these parameters. So it's starting from the pH, the turbidity, dissolved oxygen, TSS, ammonium, nitrate, total nitrogen, the COD content, and also the heavy metals, and finally the E. coli and also the total coliform content. The statistics summary of all the obtained parameters is described as in this slide. And here we have done the comparison with the water quality standard. So let me start with pH. For pH value, we can see the upper limit and also lower limit. And the pH range for both rainy and dry season is between these two limits. And we have done this study during both season, rainy and dry, because we want to see whether is there any difference during these two seasons, whether it deviates from the water quality standard or not. That's for pH. And let's go to the next part. This is for total coliform. For total coliform, we can observe here that from FF1, FF2, the value is high, but once there is a pasteurization, P40 is still showing some amount, P50 is decreasing, and starting from P60 up to P80, the TC level is 0. And for fecal coliform, also we can see here at P70 it's declining, and at P80 the value is already 0. And for EC, as we can see for EC, E. coli count here. So yeah, in first flush, there's a presence of E. coli, even in the vortex system. But once pasteurization started, at 40, 50 starts to decline, and at P60, 70, and 80 indicates zero. As for ammonium, the value is lower for starting from FF2 up to the pasteurization temperature of 80. So it means that starting from the filtration system, the quality is good enough to remove the ammonium content. As for turbidity, it's already decreased after the first flush, drastically dropped after the FF2 and also vortex. So turbidity has significant removal in FF system and also vortex system. And as for nitrate, the value is below. Starting from FF1 up to the pasteurization, the value is already low. As for TDS, also the value is low starting from FF system itself. And as for heavy metal zinc, here we can see the value is low from FF system. And for copper, the value is low also, but then there is slight increase in the pasteurization. This could be because of some of the dissolving properties from the heating element. So we can see a little increase in the copper. But overall, all the water quality parameters as tested from the treated or the harvested rainwater, it meets the drinking water parameter standard. And as for non-drinking water parameter standard is that the total suspended solid, the range is still below the permissible limit. And as for dissolved oxygen, it is between the range of 6 to 8, where up to in the vortex system. And once the pasteurization starts on, the dissolved oxygen decrease due to the heating property. And finally, the COD starts to drop after the vortex system and gradually decrease once the pasteurization kick off. So the COD level also below the limit. And also all this meets the standard requirement. Let us move on to the system performance of the integrated components. So let me summarize the individual component starting from first flush diverters. So the main function is to trap and flush away the earliest most contaminated rainwater runoff before allowing the rest of the runoff to enter the storage tank. So this is called as first flush phenomena. The device will act as the primary filter and diverter components within the RWH system. The integration of the double FF diverters were intended to improve the rainwater quality by enhancing the first flush phenomenon by diverting the more contaminated rainwater and also to induce the subsequent flushing effect through the spill and fill impact. The subsequent arrangement of the diverters were essential in creating a progressive water quality improvement prior to the next stage. And the second FF diverter was expected to contain lesser contaminants than the FF1. Whatever that is not removed in FF1 is further filtered in FF2. So can see as in the diagram here. And let's move on to the next performance of vortex filter. Here, this is how it looks. The vortex filter is like a funnel system. Due to the hydrodynamic effect or cyclone effect, the water turns in very high velocity and pass through this funnel. So the integration of the vortex funnel into the integrated system is the main novelty of the research. The device is engineered and studied to improve other rainwater parameters and not only physical separation of particles from the runoff. The vortex filter is integrated based on the concept of hydrocyclone, custom designed to induce vortex filter effect. Through the theory of particle trajectory motion to the funnel-like structure well, exerted by centrifugal force along with high flow velocity driven by gravity force, followed by a fine mesh filtration. The design vortex filter function to reduce the dissolved contaminant and fine solids following to the prior flow diversions, and the high velocity of swirling motion would induce nitrification process and self-cleaning in removing the attached lichen or mosses. And as for the performance of mild heat treatment, the design to provide dual option to the customers where the customers are free to decide the purpose of the stored water in a convenient, eco-friendly and energy-saving way. The innovative storage tank were designed to consist two different chambers with automatic sealer by ball and seat system. The inner chamber of the storage tank is equipped with thermostat heater for an automatic electric cut-off switch. The installation of thermostat heater was meant to induce the mild heat treatment to the small volume of the filtered water trapped in the inner chamber. This treatment method was mainly focusing on inactivating the coliform bacteria in order to meet 0 mpn value of the drinking water standards requirement while assessing the heat impact towards other water quality parameters. And let's look at the system performance in terms of time and energy consumed. So here we have done a comparisons of different temperature. So the column 1 is T1 is the initial temperature of rainwater in the storage tank, which is 28 degrees Celsius. And T2 is the final temperature of rainwater because we have varied the temperature, the pasteurization temperature. And delta T is the time difference between initial and this T2. And T is the time taken to reach this T2 time, and PT is the electrical power consumed. And from here we found that PAT, which require 9.78 minutes and utilize the power consumption of 0.41 kilowatt. So the electricity used to heat power and cost calculation as follows. For 6.75 liter at 80 degrees Celsius of pasteurization, which is about 9.78 minutes of 2500 watt heating element. So the calculation of the cost of electricity is shown in this table, whereby the cost per hour is 0.04 only. And for per month is 1 ringgit 27 cent. And if you calculate for per year, the cost is just 15 ringgit. That is the cost utilized for the electricity consumption to heat the water. So which is very low and it's very affordable and also energy saving. Maintenance. I would like to say that the maintenance is very easy and less maintenance is required. And finally, let me wrap up the conclusion of the quality of the parameters. So I would like to conclude that the physical parameters as stated here is achieved. For microbiological, almost 100% removal of TC, FC, and E. coli. And for chemical parameters, the removal is stated as shown here. And for heavy metals, for zinc and copper is shown here. And if you ask the question, can filtered rainwater without heat treatment be consumed? No, only fit for non-potable activities. And can filtered and treated rainwater with mild heat method be consumed? Potentially fit for potable, but further and validation from the registered government bodies are required for affirmations. So that's all from me. Thank you very much for your attention. And if there is any Q&A session, please welcome. Thank you very much.
Thank you, Dr. Lavanya, for the presentation. We are now around about 4 minutes. We are now opening the floor to live question and answer. If there are any questions to be forwarded to Dr. Lavanya. For now, I think, yeah, we are queuing one question, Dr. Lavanya now. Right, the question is from CSK. I've been told that filtration is more effective to improve the rainwater quality compared to first flush. What is the recommended size of filter used?
Okay, thank you very much, sir. For the first question about the filtration system compared to the first flush, actually the first flush, the function is to remove the total suspended solid, because this suspended solid is the one that filtered by the filtration system. So because we do not want to apply the filtration system, we want to save cost. That's why we apply the first flush system to remove the first 30% of the contaminant, and we install double. Usually one is enough, but then we install two to further improve. And at the same time, the vortex, the function is to further reduce the finer particles. Yeah, so that's the answer for filtration.
Right, in the presentation, second question is by CSK. Is there metal and E. coli on the roof, or I suppose where it's collected, right?
Yeah, we found there is a presence of E. coli. Maybe it's due to the birds dropping, or maybe because of there's some deposition of dirt. So it caused in the organic matter, it caused in the development of E. coli. So the E. coli also is removed. And as for heavy metals, only we have done the analysis for most of the heavy metals, as I mentioned in the slides, but we only found the presence of zinc and of copper.
Right. The next question is by CSK. Will there be contamination in the tank if the rainwater is stored for prolonged period of time?
Okay. Because the rainwater is just stored for according to a little portion for consumptions, and in the design that I've shown, we can tap out the rainwater at each, like in the storage. There's a dual storage. We can tap it out all the time, so there will be not much development of mosses or algae growth. So that's the function. That's a tap in each of these storage.
Suppose it could be.
Yeah, sorry, sir. Right? Yeah, and the maintenance is every 6 months. Yeah.
This next question, Dr. Lavanya, is from Ishaq Hasnan. Question is, do you make a cost study? How much the maintenance cost of the rainwater harvest system, including electricity costs? And if it is cheaper than the cost of the water that can be saved?
Yes, thanks, sir, and thanks to Ms. Isha for the question. Yeah, we have done the cost analysis study. For the maintenance, we just need to open and do some cleaning of the tap, of the each tap, and it's just incurred the cost and change because it's made of the PVC pipes, which is very affordable. So the maintenance is about 10 ringgit like that. And for the number two, for the electricity cost, as I mentioned in the previous slide, that for annually the cost is 15 ringgit per year for the heating process, because the heating is just for 2 minutes each time they want to consume the water. So shorter duration, less the consumption, and it's not boiling the water. That's why we have choose pasteurization process to reduce the cost. Yeah, and sorry, so I forgot to add on. Just now, Ms. Isha may ask, is it cheaper than the cost of water that can be saved? Yeah. For that, our system, when we done the cost analysis, it is about the cost is about 5,000 for the fixing and installation work in a household, in a housing area. It's about 5,000, including the maintenance cost. And I think it's cheap and it's affordable, and because we can use the water for multiple activities. Yeah.
Okay. Probably the last question queued here, Dr. Lavanya, is from Faisal. Can we use the home filtration system like the common use to some brands like Kobe or Puku, or those for the rainwater harvest for human consumption? There's a question on this one.
Okay. Okay, Mr. Faisal, thank you for the questions. I'm not sure how to compare Kowe and the rainwater harvesting system, but what I can foresee is that in Kowe, maybe there is a filter membrane, there's an activated carbon, charcoal, right? So this, in terms of cost, I think it's a bit little pricey. And yeah, in terms of cost. And when it comes to the system that I propose here, there is no activated carbon and no membrane filter. So, and the water quality, when we check, it meets the WHO standard. Yeah.
Yes,
So,
and quality is very important.
yes, sir.
All right, thank you, Dr. Lavanya. I think the remaining questions that are queuing in, it will be forwarded to the organizer and forwarded back to you for responses. And for that, ladies and gentlemen, we and Dr. Lavanya, we conclude the session for this morning tech session. And
Thank you, sir.
Thank you all again for having us in the track 4. And we pass over to the organizer. Thank you.